Today we're talking about antiderivatives. And antiderivatives are going to seem like they have absolutely nothing to do with what we did last week with Riemann sums. You're going to wonder, why on earth did we do this? Sometime next week or the following week, we're going to tie the two things together, okay? So Riemann sums is important. It's something that we've done. We're going to find a shortcut for doing it most of the time here in the next week or so. But before we do that, we've got to learn something called antiderivatives, okay? Those of you that remember Wynn that was here 2 years ago, after we finished with this lecture, he renamed this lecture picking the rice out of the beans. Because he said all year long we had mixed the rice and beans together, and suddenly at this point we said go in and pick out all the rice. So that gives you some indication of what we're doing. Really, we're doing the same thing that we've done in math ever since you learned to add. After you learned to add, what did you learn to do? Subtract. After you learn to multiply, what do you learn to do? And what do those things do? They undo each other. So that's exactly what we're going to learn today. We're going to learn to undo finding the derivative. It's called finding the antiderivative. Okay? So this is, in a sense, is thinking backwards from what we've done before. It doesn't have to be that complicated, but as Drew was asking me yesterday, how is this harder or easier than before? I think it's a little bit easier, but students get confused because you've been taking the derivative for 3 months now. And you're going to look at a problem, and instead of taking the antiderivative, you're going to try to take the derivative sometime. So you've just got to be careful with it and keep an idea of what you're doing here, okay? So let's first talk about what is an antiderivative. F of x is an antiderivative of f of x. Now notice that those are written differently. Capital F of x is an antiderivative of lowercase f of x if on an interval the derivative of capital F is the same as little f for all x in the interval. Okay, that's officially what the definition is, okay? So if we've got a function, the antiderivative is a function that if we take the derivative of this one, we'll get this one over here, okay? So let's look. If this is our antiderivative, if this is f prime, who can tell me what f would be? If f prime is 2x, what function has 2x for a derivative? X squared. Okay? It's pretty simple, isn't it? So far, so good. What if f prime is x? What function has x for a derivative? Well, we had x over here, so it's going to be similar to that, isn't it? X squared over 2. That would be our function there, okay? Does that make sense? And how do you know? Take the derivative of this. If you can take the derivative and get there, guess what? You got it right. If you can't take the derivative and get there, guess what? You got it wrong. So let's take a couple more before we move on to the next slide. What if I tell you the derivative is x squared? What's going to be the antiderivative? What function has that for a derivative? No, you're taking the derivative. Yeah, you were taking the derivative. We're wanting to go up. Miranda says that f would be x cubed over 3. X cubed over 3. If I take the derivative of that, 3x squared, the 3's cancel and I get x squared. So let's see. Do you see a pattern? We had x for a function, the antiderivative was x squared. We had x squared, the antiderivative was x cubed. What if the derivative were x cubed? What would be the antiderivative? X to the 4th over 4. Because if I take the derivative of that, I get 4x cubed over 4, cancel the 4, so I get x cubed.
Why are we notarizing it with capital F?
Just to kind of get you thinking, capital F is an antiderivative. It doesn't have to be that way. So, let's give you one last problem here. What if the function is x to the n power, where n is any number other than 0?
It's x n plus 2n plus 1 over
X to the n plus 1 over n plus 1. Does that follow suit with all the examples we just did? Look at this rule here. When we had x cubed, we add 1 to the power, we divide by the new power. Now, this is the most important rule for you to know in finding antiderivatives, because you will use that quite a bit. There is no product rule for antiderivatives. There is no quotient rule for antiderivatives. There is no chain rule per se for antiderivatives. This is what you will use more than anything else right here. Okay? So from that respect, it's a little bit easier. You don't have a lot of guesswork to do in how are you going to solve this, okay? Now, let's look at these two functions. Let's find the antiderivatives for those. Find the antiderivative for the first one by yourself, and then we'll talk about the second one. Answer, Drew? X cubed over 3. All right. Now, any ideas? What do you think when you see this next one over here? Quotient rule, but we don't have a quotient rule.
Same thing.
Same thing? How?
You change it to x to...
Very good. This becomes x to the negative 2. Now be very careful, because you're going to add 1 to that. When you add 1, what do you get? X to the negative 1 over negative 1, which that answer won't be on your multiple guess, I can tell you.
So it'd be negative 1 over x.
Negative 1 over x. Okay? Everybody with me there? Okay. So anytime you see a fraction, you got to figure out some way to get it into a polynomial looking thing. Otherwise, you're going to be lost there, okay? All right, so 1 over x to the 5th. Solve that problem. That's f prime. Find the antiderivative. Find f. Wes, got a solution for us? Sam, got a solution for us?
4 over x to the 4th.
4 over x to the 4th. So where did you start at there?
Made x to the negative 5th, and then took 1 away and put a 4 on the bottom.
Okay.
Negative 4 out.
X to the negative 4th, because we got to add 1. Is everybody clear on what we did from the original problem to here in f prime? We just rewrote it. Now, x to the negative 5th, if we add 1, we get negative 4. Negative 4 in the denominator. So our answer actually needs a negative sign up there too.
But why would the 4 be on top? Wouldn't it be on
Yeah,
top?
would it be... Wait, no, wouldn't it just be negative 1 over x?
Ooh, you're right. I can't move that 1. I can't move that 4 up there, can I?
Negative 1 over
X to the 4th.
1 over negative 4x to the 4th. And the negative sign has to be somewhere there, okay? Because I can't take the 4 up there. All right?
Wait, okay, we had a 4 in our answer, but the last time we didn't have another number in our answer.
We did.
I guess we had 1.
Yeah, we had 1. Yeah.
But we moved that one up, but we didn't move this one up.
Well, actually, we didn't move it up either.
It just goes away.
There's still a 1 there. There has to be something in the numerator. And I just wrote the negative sign up here so I wouldn't forget it. Remember here, I could write the negative sign where it's at, or I could put it out in front, or I could put it up here. What you did, Sam, is you took this and moved it to the top and changed the sign of it, right?
Yes.
Yeah, can't do that. Remember, if we move something from denominator to numerator, it changes the sign of the exponent, not of the argument of the exponent. So it'd be 1 over negative 4x to the fourth. All right, I have a question for you then. Look at this function. Look at this function. Take the derivative of that. Derivative, not antiderivative. What you've been doing for 3 years, 3 months. It just seems like 3 years. Take the derivative of this function g. All right? And there is a purpose behind that. What do you get? Okay. Well, wait. Everyone had an opportunity to get somewhere? Oh, uh-oh, somebody saw a light bulb. Yeah? Okay. How are you going to take the derivative of that?
You can move the bottom thing to the top, like the x to the fourth.
And make it negative.
Will be negative 1/4 x to the negative.
Okay, so you're going to say negative 1/4 x to the negative fourth. That's not g. Come on, Ely. Geez. Get with the program here. This, you're going to change it to this. Negative 1/4 x to the negative 4 plus 5. So now, taking the derivative of x to the negative 4, how do you take a derivative? What do you do with the exponents?
Multiply it by that and then subtract it.
Negative 1/4 times negative 4 x to the negative 5th. What about the plus 5? Goes away. Well, will this clean up any?
Uh-oh, I know what you're doing here now.
What do we get?
We get 1 over x to the 5th.
X to the negative 5th, because these two things will cancel out, which is 1 over x to the 5th. What am I doing, Madeline?
You're showing us that there could always be a constant, but we don't know about it because it just goes to 0. And then
Wow! Boy, you just summed that up very quickly. And it's in the morning. Wow, okay. This answer here is the same as what this problem was up here, right? So this thing here could be an antiderivative for 1 over x to the 5th. So the answer we wrote down of 1 over negative 4x to the 4th is not the only answer.
there's a billion.
There's infinitely many answers. We could add any number out here and still get the same answer. So this is called, this would be a specific solution. This here would be called a particular solution. We have to get in the habit of writing the general solution. And the general solution we write by doing this, plus c, where c is just a constant number. We don't know what c is. We don't really care at this point in time.
Will we ever care?
Yes, in about 35 minutes we'll care, okay? But we do not care what it is. We don't know what it is, but we know it could be out there. C could be 0, in which case this is our answer and life is good. C could be 3, C could be 7, C could be pi, C could be E, C could be any number. So we just know that it could be, and that we're going to leave it there. So, all right. So as you write answers, get in the habit of putting the plus C. That's one of the most common things that students leave off. Let's move to this other problem here. F prime is cosine x. What function has cosine for its derivative? The derivative of sine is cosine. So our antiderivative for cosine is sine x plus c. Okay? All right? So all your trig rules, you still got to remember them, but it's not anything new to learn, is there? It's the same thing we were dealing with before.
Just asking it back.
Yeah, we're just asking it backwards. Before we were asking you the problem and you were giving us the answer. Now we're giving you the answer and you're giving us the problem. Okay? Find the solution to the differential equation y prime equals 5. That's got a lot of words in it.
And it just basically means find the antiderivative.
That's all it's asking. Find the antiderivative. Find the antiderivative. That's all it's saying to do, okay? Well, what's the antiderivative?
Y equals 5x plus c.
Y equals 5x plus c. Everybody comfortable with that? Now, how many solutions are there to that problem?
However many numbers there are.
Infinitely many.
Infinitely many. This is called a family of solutions. You'll see some books call it family of solutions. You're going to hear it referred to more often as the general solution. Later on, we're going to learn how to find the particular solutions, though, okay? So, anytime you hear find the general solution, that's what we're talking about. All right, now, another way to solve this problem, or the more common way to see this written, is with this right down here. Okay? Anytime you see that elongated S-looking thing, this is called integration. So if I say to integrate f of x dx, this means, what this up here means is find the antiderivative of f with respect to x. So if there's other variables in there, y's and z's and r's, we're assuming they're constant. If there are other letters in there, they would be considered constants. But this says find the antiderivative of f with respect to x. Okay? I want you to look closely right now at this and this and think about what we were doing last week. Does that look anywhere similar to what you were writing down last week when you were finding the area of those rectangles?
Oh, yeah.
What were you writing down every time when you had to find the area of a rectangle?
Function and then the length.
The function, which we considered to be the height of it, and how wide it was, which was always an x value, it wasn't it? So this is kind of like the width of a rectangle, and this is kind of like the height of a rectangle. So I'm just giving you that information because we're going to tie all this together pretty soon there, okay? Notice, though, I want you to look at this algebraically, all right? This is just another way of saying that the derivative of something is a function, right? If we think of this as algebra, can we multiply both sides by dx? I mean, if I've got a fraction 3 over 4 equals 12x, can I multiply both sides by 4? And we've been doing that since you learned this, since back 6th, 7th, 8th grade. Why? Because we don't like fractions. This will get rid of the fractions for us. If we multiply this by dx, think of it in that vein, this is what we get. And I'm only mentioning that is because we're going to be dealing with these as separate things. dy over dx has been one thing for us so far this year. We really want to get in the habit of thinking of it as dy divided by dx so we can do some algebra with it. So think of it as a fraction and we can do some algebra with it from here on out. Yeah, we're really starting to pick things out apart and pull things out and things like that. So, but right now, most important thing, if you see this elongated S, this snake-looking thing, that means find the antiderivative. Okay? Find the antiderivative. Notice that we've got this plus c out here that we just talked about. That's called the constant of integration, plus c. Be sure and always put that. If you hear me talk about the integrand, The integrand is a function that we're trying to integrate, the function that we're trying to find the antiderivative of. And dx means we're integrating with respect to that variable. When you get off to college, you'll learn to double integrate. So you'll integrate with x and then integrate with y. And you'll learn to triple integrate. Integrate with respect to x and then with respect to y and then with respect to z. But that's above our pay grade. Those of you that take BC next year will get to learn to do some of that next year from somebody. The rest of you will just have to wait until college to do
What is
that.
the difference between AB and BC?
Hard. BC is, we're taking the first semester of college calculus and maybe a little bit of the second semester. BC will take the first semester and the second semester of college calculus.
Do you take some of it? It's the same thing.
Yes, we'll do everything in BC next year. She will do everything that we've done now, plus add in a few things along the way. Like we didn't talk about epsilon, the formal definition of what a derivative, what a derivative is, the epsilon delta. She'll have to do that in BC. We'll learn some more derivative techniques. We'll learn some more integration techniques and all in BC, or she will next year. So
It's just you?
right now it's just her.
There must be some
Okay, it's
advantage,
not
wouldn't there? Because you wouldn't jump a junior straight up to BC, would you?
No, theoretically you can. If you were at Oconee or North Oconee, you would not take calculus AB. You would take AP calculus BC. They take it all year long, 90 minutes a day, all year long.
Yeah, they have longer.
Right. So they don't have as much time as we do, but they've got AB. They take it all as one course, and they take AB, BC. When they take the exam in May, they'll get what they call an AB subscore and a BC. So they'll actually get 2 scores on it, an AB score and a BC score.
But like,
And most places, if you get a 4 or 5 on BC, they say you don't need any math. Go do something you need.
So,
Yeah.
what are we going to take when we go somewhere?
My suggestion would be to start off in Calculus 1, but if they tell you to start off in Calculus 2, start off in Calculus
what
2.
if you want to start off in pre-calculus?
If they'll let you start off in pre-calculus,
Because you're a history major and that's all you need.
if all you need is 2 maths, then you go take pre-calculus and something else. Or if they will let you take college algebra and something else, you go take the 2 things they'll take. Actually, what you should do is ask if you can take a CLEP test to get out of taking it altogether. They should, and they may look at your AP scores and say you don't need a math course, all you need is a stat course. But if they don't, then see if they'll give you a CLEP test and then you can get out of taking the math altogether. Okay, so have I muddied the waters enough there with everything for you to think about? We'll have more discussions about that as we go through here. Let's look at a few more problems here. Now, I put this in really just to scare you, okay? This is a list of all the derivative rules you need to know, and this is a list of all the antiderivative rules you need to know. Now, you already know all of them, or you've been exposed to all of them. This is just a good thing. What you might want to do is take this and put it someplace special on your iPad to refer back to. So if you want to take that one page and put it in a special place in Notability, it might just be something good for you to be able to refer back to for a time until you get real comfortable with all of this. But it's just there for you to use. It was in your book. You can find it online. I don't think it's in the things you need to know thing because that was pre-cal, but these are things that you need to know and will have memorized by the time you get off, by the time May 8th, 9th, whatever rolls around. So let's keep moving on. Describe or find the antiderivatives of 5x. Somebody just shout it out. Or maybe you can't shout it out. Find the antiderivatives of 5x. Yeah. 5x squared over 2 plus c. Here's the way you're going to see that problem written. And this is the solution for it right here. Okay, how do we get there? Because that 5 really throws us off, doesn't it? Okay, so remember what we're saying. Think of something whose derivative is 5x. Well, the 5's a constant number, so let's not think about it for a second. So our answer is going to have to be, or this may, and now that I think about it, this will probably help you. I could rewrite this as 5 times the integral of x dx. I can pull that constant that was being multiplied out in front. Now, what function has a derivative of x? We've done that one several times. X squared over 2. So this just means that we've got 5 times x squared over 2. Now, how could we write that differently? Well, that's the same as 5 over 1, so we could write it as 5x squared over 2 plus c. Okay? So that looks challenging, but now that we've walked through it, hopefully it's not quite as challenging for you there. Integrate 1 over x squared dx. So think about it, walk through it. I'll give you a minute and then we'll come back and look at what's happening there. Negative 1 over x plus a constant number c. Can anybody get there? Anybody got questions about what I did? You must write it as x to the negative 2. If you don't remember, what do? We add 1 to the negative 2. Negative 1 plus 2, negative 2 plus 1 gives me negative 1. We divide by that negative 1. So that's where those two exponents came, the exponent and that denominator came. We don't want to write it as x to the negative 1, so we write it as 1 over x. I'm going to normally write the negative sign in the numerator, so we just don't lose it in there. So negative 1 over x plus c. We okay with that? We're not sure. Whoa, a square root. How dare they put square roots in there? 2? Excellente. Very good. We make this x to the 1/2 power dx. So what happens from that then?
Subtract 1.
When we add 1?
Which is it? Add 1.
Yes, add 1, but
Integrate, add. Integrate, add. You need to get those things together. So it'll be x to the 3/2 over 3/2. We don't want to leave it written like that. Keep, change, flip.
So it'd be 2x over 3.
2x to the 3/2 over 3 plus c. That answer is probably not written on your multiple guess, though. We could write it like this, 2, not x squared, x cubed, the square root of x cubed over 3 plus c. That answer could be there. I doubt it is. More likely, 2x root x over 3 plus c. How did I get from the square root of x cubed down to x root x? This goes back to Algebra 2. We've got a square root. That means the way that it was taught, or the way that I taught it is, you've got a square root. 2 will go into 3 one time. That means I have 1x that I can bring outside of the square root. I've got 1x out here. I've got 1x left over when I divide. That gives me the 1x on the inside there. The x cubed means I've got x times x times x. And the square root of x squared is x, so I can pull it out and leave 1 inside. So 2x root x over 3 plus c is probably what you would see on your multiple guess there. All right, let's keep moving along. Integrate 2 sine x dx. Integrate 2 sine x dx. Somebody tell me what you're going to do first.
No sine's gonna change the cosine.
Okay. I'm going to pull the 2 out. That 2 bothers me. So I can rewrite it as 2 integral of sine x dx. So that just tells me whatever I get for my answer for integrating, I'm going to multiply it by 2.
So you're just gonna get.
Wouldn't it be negative cosine because cosine is negative sine?
Right. You know sines and cosines go together. So I'm going to start off probably writing down cosine x if I'm not sure. All right, now the derivative of cosine is minus sine. We don't want minus sine. We want sine, so we need to put a negative sign here. Derivative of negative cosine is sine, and in front of all of that, we've got the number 2. So we'll get an answer of negative 2 cosine x plus c. And the nice thing is, you know how to find derivatives. So take the derivative of this. What's the derivative of cosine? Negative sine. Negative sine times negative 2 makes it a positive 2 sine x. That's what we started with. Boom, we got it right. So you can at least check to see if you got it right there. Okay?
Oh, really funny, Mr. Ely.
What?
Hilarious.
Oh, yeah. That just blows your mind, doesn't it? What is that?
1.
We're integrating 1. Right, we're integrating 1. What function has 1 for a derivative? X does. X plus c. Now, what if I've got this?
Oh, that would just be c.
That would just be a c. Because what function has a derivative of 0? 1 or 2 or 3. A constant function does. So I could put any number there and take the derivative and get 0. You won't see that very often, but it's there, okay? What do we do if we've got 2 things in there? Integral of x minus 4 dx.
Separate them.
Separate them. How would you separate these?
X dx and minus that integration of negative 4.
Okay, now, be careful here. You either write it as subtracting integrate 4 or adding integrate negative 4. I would just write it as subtracting. I think it's easier that way. Do you have to write this step out? No. Probably in 2 weeks you'll look at that and know that the derivative is x squared over 2 plus 4, minus 4x and just write the answer down. But I would, early on until I got comfortable with it, I'd write it out as 2 separate ones. If you're unsure of this, go back and look on your sheet. You see the integral of x is x squared over 2 minus the integral of 4 is 4x plus c. There's my answer. How are we feeling here? We're not sure yet, are we?
So it's just a number by itself, it's just that.
That's right. You could think of this as pulling the 4 out in front of it and then integrating nothing or integrating the 1 like we did here if you want to. 4 things there. That just looks scary. See what you can do with that. If you want to split it up, great. If you want to just look at it and write the answer, that's fine too. You can handle that. Yeah, you can. In my head, I'm just covering up, or I'm thinking about that the coefficient is not there, and I'm just taking, what's the antiderivative of x to the fourth? X to the fifth over 5. Antiderivative of x cubed is x to the fourth over 4. X squared over 2. X. And now I'm going to clean it up. All right? I have a question for you. Did any of you just look at this and write the answer down? Okay, that's good. Now, how many times did if I wrote it out like I did up here, I integrated 4 times. Why didn't I write plus C, plus C, plus C, and plus C?
Because you have to go in this.
Because that is not what you do, and I know why in my mind, but I don't know how to explain it.
Because this is important for you to come up with, because if I wrote this problem down, this is the correct answer down here. If I choose to break it up into 4, I could logically say, well, I integrated, so I need a plus C. I integrated, I need a plus C. I integrated, need a plus C. I integrated, need a plus C.
But you don't.
C is not a constant number.
It says find the antiderivative of the whole thing as one, not a separate thing.
So I can't do it this way?
No, you can do it that way, you just can't put C's with it.
Okay.
You don't have to.
You don't have to, but actually we can. And here's the thing. These are not the same numbers here. They're 4 different. This could be 2x to the 5th over 5 plus 7, couldn't it? And this could be 3x to the 4th over 4 plus 3. So these could be C's, just separate ones. What happens when I add a bunch of constant numbers together? I get another constant number, don't I? Now, I don't know what that constant number would be. So whether I wrote it as 4 separate constants up here or 1 down here is still the same thing. This capital C here is a combination of all these little c's up here. Okay? Now, I don't want you to write down all these c's. I'm trying to just plant a seed in your head for what we're going to be doing in a few weeks so you'll know, oh, that's where those different c's come from there. Okay? So, plus 1c at the end. What I suggest you do is integrate, clean up, then put plus c at the end. Integrate, clean up, then put plus c. All right, we're almost finished. This looks like a division problem to me.
Well, we can just move it.
Then it's a multiplication problem.
This one, let's just pretend we didn't cover.
But you got to be able to do it.
We clean up the top and then clean up the bottom.
No, then it's
You
then
separate it.
move it to the meaning.
Like, okay, you move the little thing to the top.
Okay.
And then you do like, you integrate x minus 5, and you integrate x, and you integrate minus 5, and then you integrate.
But that's if it's multiplying. We don't have a multiplication rule for this, remember?
So we can't do it.
We can. If we couldn't do it, it wouldn't be here. What do y'all want to do? I mean, the only thing that I've heard,
Distribute it.
if we brought it up, we could distribute it, couldn't we? What if we did that? Let's see if that helps us any. Integral of x minus 5, and this becomes x to the negative 1/3 dx, okay? So we brought it up. Now we still can't integrate this. Now in about 3 weeks, some of you are going to want to integrate that, and you're going to, and I'm going to mark it wrong. Okay? Don't integrate that. It's multiplying. We cannot integrate at this point in time. Now we need to distribute the x to the negative 1/3. So we get the integral of x to the 2/3 minus 5x to the negative 1/3 dx. I'm adding negative 1/3 plus the exponent on this x is 1. That's 2/3. There's nothing there for the 5, so I just distribute it. Now, I don't have any binomial distribution to deal with there. What do I need to do now? I can integrate that puppy. How do I integrate x to the 2/3? Right, we add 1 and divide by that new power. X to the 2/3 plus 1 over 2/3 plus 1. Minus 5 x to the negative 1/3 plus 1 over negative 1/3 plus 1. I wrote it down just so you'd be sure and see what we're doing. This becomes x to the 5/3 over 5/3 minus 5x to the 2/3 over 2/3. How can I clean up x to the 5/3 over 5/3?
It would be 3x to the 5/3 over 5.
Minus, ooh,
15x to the 2/3 over 2.
now isn't that ugly?
But we can keep cleaning it up
Can we do something here?
with like little ruby things.
Yeah, we could go ahead and make it 3x, the cube root of x squared over 5 minus 15, the 15 cube root of x squared over 2. My guess is that answer would be there on your multiple guess. Once we get above the square roots, we don't usually clean up. We normally just leave it like that. I don't know why, that's just the rule. They started writing these rules in '69, so I don't know why they wrote them that way. Okay? So, when you see division, you've got to think, bring it up, and distribute, okay?
Alright, but what about that?
Now, we're going to have sometimes that we can't integrate. I don't know when that's going to happen, but it's going to happen. Well, what if we bring the cosine up here? We can't really distribute.
It would always be multiplication.
Yeah, it'd always be multiplication. So what do you think we ought to do? Yeah, we can. If we couldn't, it wouldn't be here.
Separate the x.
Cosine squared is secant squared. Like that. A way that's
Yeah, that's not.
But you're good thinking there.
Sine squared plus cosine squared equals 1.
Yeah. But, all right,
No.
if you look back, we don't have, let's look back for a second. We got cosine squared in our problem here. The only thing we've got to refer to right now is this. And we don't have cosine squared anywhere over here to integrate by. So, we got to get rid of cosine squared. We don't have sine squared. All right, define.
Like separate, make it cosine.
Okay? Let's see how if that's going to help us. So you're saying make it cosine x, okay? Does that help any?
Isn't sine over cosine?
Is sine over cosine something?
Yes, when you just back it.
Tan, okay. So this becomes tan x. Well, what happens to this other cosine over here?
It's still.
Exists.
Yeah, but how does it exist over here?
Oh, secant. No.
It's 1 over cosine, isn't it? dx. Now that's the crucial thing that we saw that. Sine over cosine becomes tan. This stays 1 over cosine, which you said becomes what, Colin? Secant x. Is there something that has a derivative of tan sec?
Sec tan is.
Derivative of sec tan. Derivative of sec or sec. I think it's derivative of secant is sec tan. Look back on that page and
Maybe tan is sec. Maybe tan.
derivative of tan is sec squared. Derivative of secant is sec tan plus c. See, that's you've got to be able to use your trig identities and pull that stuff out of the back of your mind there that you thought you'd never need again. Okay? That's an interesting problem. You need to be sure you can handle that there, okay? Not much more to go, and then we'll have a little time. I told you about 35 minutes ago we were going to learn how to find something called the particular solution. Very good. You're right. It's very easily. Find the general solution of f prime equals 1 over x cubed. What does that mean, dude? Take the antiderivative. Integrate 1 over x cubed dx. Well, what do we get when we integrate that?
You have to move it to the top. So you would get x to the -2 over -2.
Which becomes?
Which would become -1 over 2x squared.
And that's what our function is, right? This is called the general solution. Why is it called general solution? Because C could be anything. We want to find a particular solution. What do you think we ought to do? Plug in the 1 where?
For C.
For x. Where?
Everywhere you see an X.
Starting up here?
No, in the antiderivative.
Once we found the antiderivative, now we're going to use this piece of the puzzle right here and plug it in. We're going to figure out what is f of 1. F of 1 is -1 over 2 times 1 squared plus c, and we're told that equals 1. Can we figure out what c is? I bet we can. 1 squared is 1 times 2 is 2. We've got -1/2 plus c equals 1. So c equals 3/2. Now, this is not our particular solution. What is our particular solution? It's the function that we had, -1 over 2x squared plus 3/2. This is our particular solution. If I gave you a different constraint or different initial condition, you'd get a different C out. So if I said f of 2 is 7, you could work through and figure out what that is. F of 3 is 11, whatever it is. But this is a general solution with the plus C. Particular solution has a number solved for it there. And it's not hard to find that C, but you have to have an initial condition there, okay? Last problem, okay? And this is kind of a lead-in to what we're going to talk about tomorrow. A ball is thrown upward with an initial velocity of 64 feet per second from an initial height of 80 feet. Find the position function giving the height s as a function of the time t. When does the ball hit the ground? Okay, I'm going to focus on A part right now. And if you've had physics, if you've had physical science, you probably remember some formulas from there that you can just plug this in and poof, it gives it to you. I'm going to show you how we can use calculus to get back to that, okay? We know, even though it's not stated, that acceleration is -32 feet per second. Right? Because that's the effect of gravity. If you're up in the air, gravity is going to pull you down at a force of -32 feet per second. That means if you're 32 feet above the ground and nothing's holding you, in 1 second you're going to hit the ground. Okay? So, if we've got the acceleration is -32 feet per second squared, how could we get velocity if we know acceleration? Take the antiderivative. Well, what function has -32 for its derivative? -32x plus c. I'm going to put t because t is going to be time there. Well, can we figure out what that c is? What do we know? We know the initial velocity is 64 feet per second. What does that mean? When t equals something, V equals 64. What is
Equals initials would be 0.
zero? Initial, we normally would consider that 0. So when t is 0, V is 64. You with me on that? So now, so we plug this in over here, and we get V equals negative 32 times 0 plus 64, plus C has to equal 64. Therefore, C equals 64. So, we were given our acceleration. We figured out that our velocity is negative 32t plus 64. We've got velocity. How can we get position? Take the antiderivative. Okay? If you go back and remember 3 months ago, if I gave you position, you could take the derivative to get velocity. You could take the derivative again to get the acceleration. I started off with the acceleration. I took the antiderivative to get the velocity. We're going to take the antiderivative to get the position. What function has negative 32t plus 64 as its derivative? Well, we've got negative 32. What's the antiderivative for t? T squared over 2. What's the antiderivative for 64? 64t plus c. Now, I'm going to write it as c1. Is this c going to be guaranteed to be 64 like it was up here? No, it's a totally different c, okay? So I'm going to put a different mark there so I know it doesn't have to be 64. Well, we need to figure out what that c1 is. What do we know? When t is 0, s is 80. When t equals 0, s equals 80. So guess what? If over here, if we put in 0 for t, we get out c equals 80. Now, I just did that in my head. Are y'all okay with that? When t equals 0, s equals 80. I just plugged 0 in for this t and this t, and I got 80 out. So suddenly now I know the position then is negative 16 t squared plus 64 t plus 80. So I found my position function by integrating twice, by finding the antiderivative twice. And if you go back and look in your physical science books, that's the same formula as what you'd have there. When does the ball hit the ground? Tell me how you would do B part. No. For B part, we're going to set S equal to 0. There's no challenging that, okay? An Algebra 2 student can solve that problem. So you'd set it equal to 0 and go, we're not going to waste time to do that. You're smart people, you can handle that. Very good. Any questions?